Centuries after Lady Margaret Beaufort engineered the birth of the Tudor dynasty, scientific tests have uncovered biological traces on her private possessions. These traces point to secret ailments, forgotten medicines, and hidden political weapons. These unprecedented findings, absent from any royal archive, threaten to rewrite what we thought we knew about the woman who shaped England's fate. What hidden truths linger on her most intimate artifacts? In the hushed vaults of cathedral libraries and private estates, every artifact attributed to Lady Margaret Beaufort is tracked with a precision that leaves little to chance. The prayer book folio, catalogued as QP147, carries not only her name in the accession ledger, but a sequence of signatures that trace its journey from Tudor hands to modern archives. A slender quill, listed under ES009, appears in the estate inventory of 1503. Its provenance confirmed by the wax seal of the Beaufort household, pressed into the margin of the original ledger. The letter bundle LMB12A, bound in faded silk, bears archival stamps from both St John's College and the Chapter House at Westminster, each entry in the register cross referenced with notations from 16th century curators. A length of embroidered textile, TS77, surfaces in the Christ's College donation log, its chain of custody uninterrupted since the reign of Henry VII. Each object's identity is supported by a paper trail of ledgers, stamps, and signatures, evidence that leaves no ambiguity about their origin. Before any scientific inquiry begins, these records stand as silent witnesses, confirming that the items under scrutiny truly belong to the woman whose decisions shaped the fate of a dynasty. Securing access to artifacts attributed to Lady Margaret Beaufort required a formal process that left a detailed paper trail. Before any scientific sampling could begin, curators at each holding institution reviewed written requests outlining the rationale for microsampling and the measures in place to protect the integrity of these centuries-old objects. Signed authorization documents, some bearing the seals of cathedral chapters or college boards, specified which items could be handled, the maximum allowable sample size, often less than a milligram, and the precise locations from which material could be taken. Conservators and archivists worked side by side to establish strict protocols for storage and handling. Each object was transferred to a controlled environment, with temperature and humidity logged before and after sampling. All tools and containers were sterilized in advance, and chain of custody logs tracked every movement, from the moment an artifact left its archival case to the instant a sample was sealed for transport to the laboratory. Permission letters now reside in the institutional records, documenting the ethical stewardship expected of researchers entrusted with Tudor-era materials. These safeguards were not only legal requirements, but a reflection of the care demanded by artifacts whose historical significance reaches far beyond their physical form. Only after these permissions and protections were in place could the scientific procedures proceed, ensuring that every subsequent step would meet both scholarly and conservation standards. Inside the laboratory, every precaution is taken to protect both the centuries-old samples and the integrity of the results. Technicians suit up in full protective gear, disposable gloves, sterile lab coats, and filtered masks before entering the positive pressure clean room. This environment, regulated by HEPA filtration and monitored for airborne particles, keeps out modern contaminants that could overwhelm the faint biological traces preserved in parchment, textile, or wax. Sampling begins with tools designed to minimize disturbance. Polyethylene erasers are gently rubbed across the surface of vellum and parchment, collecting microscopic debris without damaging the underlying script. For tougher substrates, a microdrill extracts tiny core samples, never more than a few milligrams, from inconspicuous edges or margins. Sterile swabs moistened with nuclease-free water lift proteins and DNA from delicate embroidery threads or the crevices of a wax seal. Each instrument is single-use and pre-sterilized, with handler DNA profiles recorded for later cross-checking. The risk of contamination is always present. To guard against false results, extraction blanks, empty tubes processed alongside actual samples, serve as negative controls, and positive controls contain known DNA from comparable medieval materials. Every sample, blank, and control is logged, labeled, and sealed immediately after collection. Chain of custody forms accompany each tube, documenting every handoff from the moment of sampling to final storage in the deep freeze. Only after these rigorous steps are complete do the samples proceed to molecular extraction, ensuring that any genetic or biochemical signal detected can be traced back to Lady Margaret Beaufort's world, not to the modern laboratory. Mass spectrometry data from the vellum folio QP147 reveals a pronounced peak at 200.6 mE/Z, consistent with inorganic mercury. Adjacent signals at 167.1 mmOV/Z and 173.2 mOV/Z indicate alum-derived potassium and sulfur compounds. Extracted ion chromatograms show a distinct cluster of steroid metabolites, most notably a spike in cortisol breakdown products on the lower margin of the letter bundle LMB12A. Peptide mapping of Quil ES009 identifies keratin fragments matching the expected sequence range for human epidermal tissue, with demidation rates characteristic of late medieval preservation. Pigment analysis of wax seal impressions uncovers copper arsenate particulates distributed in a concentric band, with energy dispersive X-ray spectra confirming elevated arsenic to copper ratios. SEM images of these seals highlight microcrystalline pigment clusters embedded within the outer wax, suggesting intentional incorporation rather than incidental contamination. Margin swabs from the embroidered textile TS77 yield low-abundance botanical alkaloids, including traces of berberine and salicylate, mapped by high-performance liquid chromatography. DNA quantification returns fragment lengths averaging 78 base pairs, with a right-skewed distribution and cytosine to thymine misincorporation rates above 12% at red termini, consistent with authentic ancient DNA. Control samples remain negative for target analytes. The raw data, annotated spectra, and pigment distribution maps are logged for each artifact, with every result referenced to its corresponding chain of custody entry. These outputs offer a direct, unfiltered view of the molecular signals preserved on objects once held by Lady Margaret Beaufort. Subscribe for more groundbreaking historical investigations. The presence of mercury and alum on the vellum folio recalls the medical routines of the Tudor court, where these compounds served as ingredients in treatments for wounds, fevers, and chronic ailments. Medieval pharmacology manuals list mercury as a remedy for persistent skin conditions, and alum as a drying agent, both common in the apothecaries' chests of the nobility. A medical historian notes that these substances, while potent, often left lasting traces on personal belongings, a silent record of ongoing care and physical hardship. Turning to the wax seals, the discovery of copper arsenate pigments aligns with the documented use of green inks for confidential correspondence. Pigment specialists point to recipes from the late 15th century where copper salts and arsenic were blended to produce colors reserved for encoded or urgent messages. These specialized pigments, embedded deep within the wax, suggest deliberate selection for communication that required secrecy and rapid recognition. Each compound and pigment preserved across centuries connects the artifacts not only to routines of daily health, but also to the undercurrents of political maneuvering that defined Margaret Beaufort's world. Each artifact sampled for molecular analysis represents a delicate compromise between discovery and preservation. Conservators stress that even the smallest removal, measured in fractions of a milligram, can never be undone. The rarity of intact Tudor-era materials means that every intervention must be justified not only by the potential for new knowledge, but also by a duty to future generations. As a result, all sampling strategies are designed for minimal impact, with protocols calling for the least invasive techniques and thorough documentation of any material loss. The resulting data, though groundbreaking, are only as meaningful as the care with which they were obtained. Curators now invite researchers across disciplines to study the published protocols and consider replicating the analysis on comparable artifacts, urging a transparent, collaborative approach. The hope is that by sharing methods and results, the field can expand its understanding while safeguarding the physical legacy that remains. The story of Lady Margaret Beaufort's world is far from finished, and it now depends on the choices made by those entrusted with her memory. Centuries-old secrets still live in the smallest traces. As science rewrites what archives can't reveal, every artifact holds the potential to alter history's verdict. The real power of the past lies not in what is recorded, but in what waits to be discovered. Subscribe for more groundbreaking historical investigations.